Hola, welcome to our presentation on graph neural networks that learn Twitter bot behavior. This is a joint work between myself, Albert, Sasha Levy, and my supervisor, Rehane Rabbani from Mila Institute and McGill University. In the current times, social media provides a crucial scenario where freedom of speech puts democracy at stake. With the rapid flow of information, it is not surprising that malicious attackers often target Twitter users to take political advantages, as reported in recent literature. This world fact, along with recent events, has inspired us to study how state-backed accounts, namely bots, behave differently from real users. In this project, we model such behavior using a link prediction task on large networks from Twitter. A few years ago, Twitter's transparency operations started releasing a huge set of accounts, each of which has been manually identified to perform state-backed operations. Twitter proceeded to suspend those accounts and disclose their activity publicly, without sharing the real user IDs. Such activity includes the spread of disinformation via hashtag manipulation, meme spreading, and massively coordinated activity within bot communities. Following the official reports, refer to this set of accounts as a Twitter election integrity dataset, which includes over 800,000 hashtags, 2 million users, and all of which come from around 22,000 suspended fake accounts. On the other hand, we will contrast our findings with 67,000 currently existing accounts that have made use of over 36,000 hashtags and 171,000 mentions. We have crawled this data during the early months of the COVID-19 pandemic. To make sense of what the reported users are talking about, we sample a set of hashtags and rank them using their inverse document frequency score. By looking at both ranking extremes, we are able to see the kinds of topics that are of global interest, regardless of any account's country of origin. Moreover, on Table 3 we provide a sample of popular hashtags per country, which turns out to rather target particular events. We now propose two ways of reconstructing a large-scale social network from the provided data. On the left, we present our mention graph, which simply links bots with mentioned user accounts. Now on the right, we picture our mentioned hashtag graph, which is similar to the one on the left. This time, though, the hashtags form another node type. We propose a deep learning pipeline in order to learn a link prediction model from the proposed graphs, which we divide in three steps. First, we sample a set of tweets from a predefined interval. Note that this process can be performed either on the Twitter integrity dataset and on the real user one as well. We also sample negative links that will help us define our link prediction task on later stages. Next, we build node attributes per each user. We experiment with two alternatives. The first one being node-to-vec algorithm, whose idea is to characterize a node in terms of its closest neighborhood. We also experiment using the metapath-to-vec algorithm, which builds on top of node-to-vec, but predefines the types of paths the algorithm could only traverse. Finally, we choose the SEAL framework, which is a graph neural network architecture with node labeling, to perform our experiments on link prediction. As part of our ongoing experiments, we report our accuracy scores from sampling subsets of data. We find that on average, our model achieves a higher accuracy when predicting links of the Twitter election integrity dataset. So to summarize our ongoing findings, we are able to learn a model from time-invariant samples that shows greater performance on coordinated activity rather than on existing real users. As for the future, we would like to explore more how the underlying node embeddings help us to tackle downstream tasks such as misinformation detection or polarization measurement. Finally, we encourage modeling this task on a temporal setting, which users' dynamics will provide better insights on coordinated activity. Thank you for your attention. Please feel free to reach out for further information, and also don't forget to check out our poster at the LatinX workshop. Hasta luego!